I'm here together with Juan, that is the person that you can find out there in the corner, that is a co-author as well for this paper. And I will be speaking mostly about federated learning because I want you to grasp the idea of federated learning. And then I will move into the simulation tool that we have built for a European project. So please, the next slide. So this is the structure that I will be following. So firstly, I will start by the explanation of federated learning. So what is it? How does it work? And why is it, let's say, decent and an alternative for the future? Then I will move into the simulation tool, and at the end, I will close with some conclusions. Please, the next slide. So first, what is federated learning? So federated learning is a learning algorithm that supports training process of models along decentralized data. So on the right-hand side, you can find, let's say, a diagram that shows how this process more or less works for a health data federation. So you find that there are several data sites that are the ones on the right that have a local learner that is a copy of the model. And then you have another entity that is the federated server or the aggregator. So these two can interact, but there is no data exchange. So there is just a exchange of parameters. And here how it works is that the central node stores the global model, and the data nodes store local copies of these models that can adapt, and then some information is shared, but never related to the data itself. Next slide, please. Okay, so how does it work? So here the two main steps are the third and the fourth one. So in the third, you can see that the data nodes have a local copy. So this copy or the local learner is trained against the data that is stored there. And then the model is transferred to the central aggregator. So the central aggregator combines all the, let's say, this incremented information or knowledge that it has. And then it broadcasts this model, the newly generated model, to all the data nodes. So these two stages occur iteratively, and this is how the learning algorithm works. Next slide, please. So why federated learning? So first, now the policy, the regulation scope is getting more and more strict due to the fact that we are treating mostly sensitive data, and within this project it was the case. So this is a way to achieve model training in, let's say, in this scope. So when there is a regulation that is pushing you to comply with GDPR, etc. Also, it supports novel approaches such as deep learning. Now, deep learning, as you know, it is the most common way of training models, or the most common model, let's say, scope. And also can leverage on further privacy and protection mechanisms, such as secure multi-party computation and differential privacy, that tackle also some security concerns that this algorithm can introduce. So next slide, please. But also it comes with a cost. First, because there is a leap in complexity with respect to traditional machine learning for the end user. I mean, as an AI practitioner, of course, you need to get in touch with a broader areas, or a wide variety of areas, not only because you need to know how the model itself works, so the local learner, but let's say, but also how the aggregation is done, how everything is deployed on site, etc. And also because in general there is humble hardware if you compare it with data centers. So in data centers, it is, let's say, done in a centralized manner. So you have a giant server that can train really large models. But here normally we are related to imagine phones or clinical sites that they cannot offer these kind of resources. And lastly, because you have some unpredictable behavior. Normally, when you are talking about model training, you introduce, let's say, some unexpected behavior, but here because you have also the algorithms itself, let's say several configurations in terms of data, what is the amount of attribute that is present on each of the data set, etc. So there is also this kind of uncertainty. Next slide, please. So now let me move into the proposed simulation tool. So on the right-hand side, you can find an entity relationship diagram. So this is how more or less the information is configured within the application. So you have first what we call use case, that is a collection of scenarios with different configurations in terms of the absence or presence of data. So where are null values, if all the columns are there, etc. That are the ones on the right, the scenarios. And then also you have, let's say, some target that can be classification, regression, whatever. And then you relate this with a federated learning task that, of course, gathers some results, and with a model. So the model is the model that the AI practitioner handles to the platform, to this simulation tool. And let's say that this model is presented against all the scenarios, and some of the results, all the results are gathered and conveyed to the end user at the end. So these are the features that allows, besides the definition of use cases and all these things, we have that this model can be simulated for some meaningful scenarios, and also that we can leverage an automatization. So the operational level of this tool guarantees that we not only have the automatic training and evaluation that normally federated learning releases, but we also have automatic verification of the model, so that we can guarantee that the model runs properly, and that you can grasp let's say an overview of how the model performs with respect to some related data. Next slide, please. So these are some of the benefits that we try to offer. So first, that we can validate that the federated learning model runs without any kind of error. Then that we can optimize the resources in the federation itself. So if we can have a simulation prior to the deployment environment, then we can know whether this model should be put into production or not. I think that this is really useful and related to the ideas that you were discussing just before. Also, it gives a sense of the performance of the model across different use cases that can be ad hoc defined in an ad hoc manner. And also that it runs on a multi-container setup. It can be deployed anywhere because this is the way that virtualization and containerization works. And on the right, we can find how, let's say, an architectural diagram. So you can see that there is the entry point server. Then I will focus on the top part because I think it is the most important one. So there is a broker that sends the task over a cluster of executors, and these executors fork several processes so that the simulation can proceed. Of course, this is scalable in the sense that the more executors we have, the more tasks can be simulated simultaneously. Next slide, please. And lastly, I would like to convey to you, let's say, the two most important ideas that we have here. So we offer a tool that can be used both standalone and also embedded with our architecture. So we have also defined a platform that works on top of a framework that is really used right now in the industry and in the academia, that is called Flower. So we have managed to cover Flower with containers and with this tool in order to leverage on federated learning for healthcare in this European project that I am mentioning. And of course, this is concurrent, scalable, and it provides a high availability for verification and validation assessment for federated learning models. And the second idea is that we can support AI practitioners in the process of integrating federated learning-driven model designs, let's say, in their workflow, because this is normally hard. It is not the same, as I already mentioned, to create or to design or even to deploy a traditional machine learning model than to do so with a federated learning model. And also, you can grasp model performance prior to the production scenario. Of course, this allows a boosting trustworthiness towards ethical artificial intelligence. Yes.
Does the simulator allow you to deploy any kind of statistical model in the federated learning?
Here we have the limitation that federated learning cannot train anything. I mean, cannot train every model. But besides that, yes. Of course, for example, in this project, we needed also to establish some limitations in terms of what are the models that can be deployed, etc. Because at the end of the day, this is for AI practitioners, so they want to do this process in a transparent way. Of course, if you go in a lower level of detail, then you can run any model. But in the specific case that we had, we needed also to limit a bit the environment, because otherwise it would be really complex to guarantee that all the different model programming languages, etc., can all convert into, let's say, an automatic deployment of a federated learning model into all the data sites and to run everything automatically. So the answer is depends.
Eventually, the simulator would deliver performance measures as well for the.
So yes, you define. I mean, the user needs to define the way that a metric is gathered from the performance. Also, you have some data, then the model gets trained, and you have some validation data. So automatically, it, let's say, achieves that this metric that has been defined by the user is evaluated across the validation data for different scenarios.
I guess it is possible to delegate this task to an external API for calculating the measures.
Yes.
Continuation question linking to the previous discussion with the energy.
Okay.
Do you imagine something similar to be done for modeling the energy consumption?
Yes, I mean, federated learning is mostly suited for, as you know, decentralized data. So in a world that we are moving many computations to the edge, of course, it is. I mean, it is a decent approach. There are other approaches. I mean, in the once you have decentralized data, then you need to some solutions as this one, because you are forced to do so. Of course, I mean, this if you compare this approach to having all the data in a centralized version, the centralized version will be better in the sense that it has at every time has all the data. You don't need to aggregate everything, but yeah, it will definitely work.
But perspective is that if you are federated in an IoT device are not very dependent. For example, like to have the energy estimate. So that's kind of right.
You are right. So in our experience was not so much related to IoT, was related to healthcare data sites. So we had some servers, let's say, were humble, but we have not moved into this path of, let's say, IoT. But of course, it is desirable to.